So, Steve, thank you so much for offering to present yet another program on the Gulf of Maine. And thank you all for being here.
Right. Thank you, Suzanne. And again, I'll thank everyone for being here too. As I said, it's always great to look out and see a bunch of people out there. Let's start in with the Gulf of Maine. I'm going to start sharing my screen. Yeah. Okay. Cape Cod. Oops. All right. Yeah. This is an area, obviously it's a view of Cape Cod from the International Space Station. Here's the Cape itself right here. Provincetown would be over at the tip right here. This right here is Cape Ann, and Boston itself is situated in this area about here. Over here is Martha's Vineyard, and there's a little bit of Nantucket that's in that picture too. Okay, and the Cape is broken up into different areas. It starts out, the closest to the Massachusetts proper is the Upper Cape. And then you go to this orange area, which is considered the Mid Cape. Over here in the pink area is the Lower Cape. And then this arm that goes up against the Atlantic is the Outer Cape. And this is the welcoming committee, because there have been a resurgence of white sharks at the Cape over the last few years. And here's a close-up of a white shark. And, I included it because it really is a beautiful fish. But if you look at it, and you'll notice that right up here, it looks like there's a number of cuts and potential injuries. Back here, behind the gills, it also looks like there's some cuts. There's two ways that the white shark might get those cuts. If the shark was going to eat a seal, and white sharks generally like to eat large marine mammals, the seal might put up a fight and cut the shark up. Being a predator can be dangerous at times. But the other reason why some of these sharks have these cuts on them is because during mating, the male shark has to grab a hold of the female. And the only way that the male shark can grab a hold of that female is by biting her. And that's what happens, is they bite to hold on. And because of that, some female sharks have developed skin that's about 2 to 3 times thicker than that of males in their back, their abdomen, and on their flippers. What are the sharks there for? Well, since I think about 1972, the Marine Mammal Protection Act was put into place. And since then, the seal population on Cape Cod has gone up quite a bit, which is with as many as 50,000 in that area at the same time. The majority of the seals in the Cape Cod area are gray seals that live there year round, and they're a larger seal. They go from 550 to 850 pounds. The other seals that are prominent in Cape Cod are harbor seals. They are seasonal residents. Okay, they're there for their mating season. They're there from May to September, and they grow 100 to 300 pounds. They're considerably smaller than the gray seals. One thing too about the Cape Cod Bay, and actually the Stellwagen Reserve, which is adjacent to it, it's a feeding and nursery grounds, especially for North Atlantic right whales and humpback whales. Okay, talking a little bit here of how did Cape Cod form? In the last 2 million years, there have been at least 4 distinct glacial periods. And by a glacial period, I mean an ice age. The last one was occurred between 85 and 16,500 years ago, when most of all of Canada and much of the continental United States was covered by the Laurentide ice sheet, up to a mile, 2 miles thick, depending on where you were. Cape Cod itself formed 15 to 10,000 years ago as that glacier was melting and receding. And this sketch over to the left, the green shows it's pretty much the extent of the ice sheet in the last ice age. The this brownish pinkage is the exposed continental shelf, and down here is the ocean. Because remember, the ocean was the sea level was a lot lower during the last ice age. Cape Cod itself was formed by moraines and glacial outwash plains. And the shape of the cape is due to the erosion of those glacial deposits. About 6,000 years ago, waves began eroding those glacial deposits, and longshore currents carried the eroded material along the length of the cape, forming sandbars, sand spits, and barrier islands. We'll be talking a little bit more about longshore currents a little further in the presentation. But if you notice, like with this sketch, oops, with this sketch here, you can see over to the left, the ice sheet is coming down as far as Martha's Vineyard and Nantucket. And over on the right, the ice sheet has receded. And you can see that these dark pink lines here are glacial moraines that were left piled on the earth. And this lightish brownish pink is a glacial outwash plains. Okay. In the event that folks don't know what a moraine is, it's a glacial deposit. And you might remember I might have heard of glaciers as being a river of ice. And one of the things about rivers is that they flow. And so what happens, a moraine is formed when the ice is flowing at the forward movement of the glacier is equal to the rate of melting. And what happens is that glacial material will all be put into one pile. And that would be boulders, sand, whatever is in the glacier will come here and be dumped there. That's what formed Cape Cod. And it really is a conveyor belt effect. This is another picture that shows a little bit more about what I'm talking about here. This right here would be a terminal moraine. That's where the glacier ended, and it's the conveyor belt effect is starting. After the glacier has melted away, as you'll see in the second picture here, you'll see a pile of glacial till or moraine, and behind this moraine, lower where the ice was, the water is still draining. And when it drains through and it cuts through the moraine, it basically forms an outwash plain. And an outwash plain could be, it's sandy, and it'll be sedimentary sediment that's actually stratified according to size on that outwash plain. This is an example of a current day outwash plain up in Alaska. And this is similar to what you would have expected to happen when Cape Cod was forming. About 12,000 years ago, if you look at this picture right here, you will see that much of all the land around Cape Cod, Martha's Vineyard, Nantucket, there was no water there. And Stilwell and Bank, which is a national marine preserve, and I have a little bit more about that later, was actually above the ocean. By 8,000 years ago, the relative sea level was about 60 feet below what it is today. And the changes that you see to Cape Cod and all these land masses here are due to the sea level rise, waves and currents that hit those sediments. And I wanted to make note here that Provincetown itself, this tip, was not formed 8,000 years ago. Cape Cod is one of the world's largest barrier islands. There's about 2,100 of them in the world, and they make up about 10% of the ocean's ocean boundaries. Cape Cod itself is bedrock covered by glacial deposits. The glacial deposits themselves, it's till and sand, whatever, is 200 to 600 feet thick. And those deposits are resting on bedrock that is at an average depth of 300 feet. Glacial sediment today goes up to 4 miles offshore from the present coast of Cape Cod. And that's per the U.S. Geological Survey. Some of the ecosystems on Cape Cod: marine, estuaries, freshwater, and terrestrial. The terrestrial land is covered by pitch pine, scrub oaks, heath, grasslands, and dunes. And dunes cover about 1/3 of the land surface on Cape Cod. Where'd the sand come from? Well, most of it, well, actually, I should say this, all of it came from glacial deposits at one time, but a lot of it was also exposed by poor land use practices of the earlier settlers. And between the poor land use practices and there being a bunch of sand underneath the land or on the land, erosion and deposition took place, which pretty much formed the Cape as to what we see, how we see it today. This is sand from the beach, from the outer Cape sand, and this would be on the Atlantic side of the Cape. And if you notice this magnified sand, the magnified sand grains, all different colors, you know, there are many different minerals that are mixed into this sand. But when we look at it as human beings, our mind blends it into this brown color. So really, when you look at the sand under magnification, it's quite a bit more colorful than what we would see on the beach itself. Much of the Cape has what you call marine scarps. This is soft sediment. It slopes at 30 to 35-degree angle. And some of these scarps, especially if they have a fine clay sediment, they can reach up to 150 feet high. They erode at a rate of about 3 feet a year. And this is the beach right here. There's the ocean. Here's the scarp right here. This happens to be at the Lacotte Hollow Beach on Wellfleet. And this is another example from that same beach, but there's a higher clay content to the soil or to the sand, and you can see that there's a little bit of a steeper angle to the scarp. This is Marconi Beach in Wellfleet. And these sand scarp, this is a sand scarp here, it's about 40 feet high. The reason I mention this is because in 1903, Marconi, who invented the radio, made the first transatlantic wireless transmission from Wellfleet, Massachusetts. And if you notice these tall poles here, these were they had set this series of poles up, and they had run a series of wires through them and around them to make their antenna for their transatlantic transmission. And that effort and the story about that is actually in a book called Thunderstruck by Eric Lawson. And it's well worth reading because they went through a lot of hassles to get this thing to work. talk a little bit about tidal variation. If you look at the Cape Cod Bay side up the Massachusetts coast, we have you're seeing tides 8 to 10 feet. And that's roughly what we see in Wells, Maine, which is about 10 to 12, I think, at the most. What causes tidal variation? Wind and currents. We have a big current here, the Gulf Stream. That affects tide height quite a bit. Also, the shape and the depth of the body of water and what the surrounding landform looks like. So a lot of the tidal variation is based on wind, currents, and what the topography of the land looks like. This is a picture of the Brewster Flats. They extend a mile out at dead low tide. And dead low tide occurs when at the point where the tide is actually at its very lowest point, it literally stops and reverses and starts coming back in. Dead low tide. The Brewster Flats are the largest flats in North America. They're nearly 10 miles long. They include about 3,500 acres of tidal flats and almost 700 acres of salt marsh. And this is Brewster right here. And over these dotted line here shows the extent that the flats will go out into the Cape Cod Bay. This is another picture of the East Brewster tidal flats. And I included it because it obviously shows a lot of low-lying sand, but there's also some cobble mixed in here. So you got a little bit of variation in the beach. These are tidal flats. The tidal flats themselves extend through Brewster, Orleans, and Eastham. So they go quite a bit of ways along the coast. And I included this because it's quite interesting that Cape Cod is based on sand, it's glacial till, and you have like salt marsh that grows on top of the sand. And this looks like, with this river here, looks like it's an estuary. So it's a type of area that you might expect the salt marsh to form, but it's different to see, for me anyway, it's different to see a salt marsh on sand as opposed to what we normally see here in Maine. This is a part of the Cape called the Province Land, and it's the northern tip of Cape Cod. And if you look at this, you'll kind of see that the trees look kind of scrubby. These look like pitch pine, and there's quite a bit of exposed sand in the area. Okay, and this is the Province Land itself is a dune area, and it's very close to Provincetown. And if you look at the dunes themselves, you'll see that there are some places where there's shrubs, there's some grass on it, growing on them, but there's a lot of places where the sand is not covered. So this is really kind of an unprotected type of shore. If it was too close, if too much water hit it. Originally, the Cape was covered by hardwood forest. When the Pilgrims first landed in Plymouth, actually they landed closer to Provincetown, but when the Pilgrims first landed, the Cape Cod was hardwood. By 1800, it had been deforested. And about 150 years ago, pitch pine and beach grass was planted throughout the Cape for erosion control. And today, Cape Cod is about 80% forested. But the forest, if you look at it, are not necessarily those beautiful hardwood forests, but they're kind of scrub oak and pitch pine. And this shows an example of a pitch pine on the outer lands of Provincetown. And this is the area that's still recovering from just deforestation that occurred before the 1800s. And you can see that there are large areas covered with bare sand. And I'm looking at this pine tree here, and I'd be really curious as to exactly how old it is, because it's probably a lot older than its size would have us think. This is dune sand. These are dunes in at Provincetown, and you can see that they're U-shaped, and they kind of repeat the pattern throughout the landscape. Dune sand itself is lighter in color and weight, and it's also finer than beach sand. And the dune sand itself is mostly fine grains of quartz, which would make it very light color. And the dunes themselves in Provincetown can be 40 to about 100 feet tall. This grass here is American beach grass. It is the primary plant that grows on the dunes. And it does well there because it tolerates heat well, it tolerates dryness, and it can stand up to being sandblasted when the wind blows the sand against it. American beach grass is native to the eastern part of North America. Okay, these are the province land, okay? And province land is out by Provincetown. And this it was formed by a spit over the past 6,000 years. And that sand that made Provincetown was eroded from the oceanside cliffs. And wave refraction, when the wave hits and changes in angle, helped form this tip around the hook of Provincetown. And while we're looking here, I'd ask to pay attention to this sandbar that's on the outside of Provincetown. Okay, this is that sandbar right here. Okay, and and this whole area of Provincetown was formed by longshore currents. And these were mentioned a little bit earlier about erosion of the sediments, of the glacial sediments. What happened is the angled waves that hit, and the angle that changed moves the sand along the shore at Cape Cod at a speed of about 2 to 3 miles per hour. Where the coast will bend, the current slows. When the current slows, the sand will settle, forming a sandbar, then a sand spit. And eventually, as it gets right here, eventually the amount of sand is such that it accumulates above the high tide level, and it's called habitable land. The province lands themselves are basically a large sand spit. Now, this Peak Hill bar is the same sandbar that is off the coast in this picture right here. And it has been in a similar form and location since colonial times. So in the last 250 years or so, 300 years, hasn't really changed that much. But eventually, scientists feel that it will probably accumulate enough sand and become an extension of the province lands themselves. The soil on the Cape is very porous. It's sand, glacial till. But there's another type of soil called podzol. And that's a Russian word for ash soil. And I believe what you're looking at is this right here. And it appears as white or gray ash due to leaching. This type of soil is extremely acidic, holds little water, and it doesn't have very many plant nutrients. It does support some pine and oak species, but they tend to be small with stunted growth. This is the Great Subswishet marsh in Falmouth, Mass. And I included it because I think it's a really pretty well-defined marsh. But also, if you look at here, like this beach right here, this is either a barrier island or a barrier beach. With a bigger picture, I'd be able to tell more. But no matter what, this beach here is what probably allowed the salt marsh to form in this area. Going a little further in Falmouth, there's another beach called Black Beach. And mind you, Falmouth is an area that has lower tides, maybe 1 to 2 feet at most. And you can see there's certainly not much of a drop off along this shore. This is a salt marsh. It's at Hatches Harbor, which is adjacent to Race Point, which is right at the tip of Cape Cod. And I included it because, again, a lot of salt marsh, and it's on a sandy substrate. You can see from this picture here, there's dieback in the salt marsh, and this happens to be a great harbor in Wellfleet, Massachusetts. And this is showing some more salt marsh dieback in another spot in Wellfleet. And the character or the responsible, I just got something on my phone over there. Excuse me. The reason or the damage that has been done to the salt marsh, a lot of it has to do with the purple marsh crab. This is it's kind of a giant purple marsh crab. The area between this carapace, pretty much between here and here on a real life marsh crab would be about 1 inch across. It's a native species, not an invasive. It's not been introduced, but recently it's had a population explosion due to overfishing of its natural predators, which include cod, striped bass, and dogfish. Okay. What these purple marsh crabs do is they eat marsh grass on the surface. They'll chomp it off, and when it starts growing again, they'll actually chomp it off a second time when they're small. But then the larger crabs will tunnel. And this is an example of some damage to the salt marsh that's caused by the purple crab. You can see that the peat is knocked down, and a lot of the grass and the roots is also, you can see the roots are kind of exposed. And these are tunnels, an example, and remember, these are small crabs, so these tunnels have eroded and gotten quite a bit bigger, but you can see how it leaves the salt marsh. And, when a storm comes and it hits peat that's full of holes and been degraded, that means that the salt marsh is likely to get damaged, and it certainly doesn't stand to provide as much protection for what's further ashore when it's getting beat up at the end. These are kettle ponds on the Cape. And a kettle pond forms when a chunk of glacial ice lands and it is buried by glacial sand, till, boulders, or whatever. Eventually, the ice melts and it leaves a pond, a kettle pond. And if you look at this photo from the International Space Station, you'll see there are a lot, there are a lot of water bodies here on the Cape and also up here into Plymouth. Okay. When the ice melts and it leaves a large, deep crater, if that crater becomes filled with water, it's considered a kettle pond. If there is no water in it, it is considered a kettle hole. And in Massachusetts, in this area, there are many commercial cranberry bogs in those kettle holes. Oops. And here's some kettle ponds here. They tend to have steep sides and banks. Remember, it's a chunk of ice that was in the sediments that allowed it to be formed. The ponds themselves tend to be 25 to 75 feet deep. They range in size from less than an acre to 735 acres, which is the largest. And about 11,000 acres of the Cape is covered with kettle ponds. This is kind of interesting here. The kettle pond water levels can be 6 to 32 feet above sea level. And the pond water level is determined by the groundwater level. Here's an example of a cranberry bog, and obviously it's flooded. And the way the bogs work, they flood and drain them depending on what part of the production that they're in. This is a cranberry bog after it's been harvested, and it's the bog itself is in Plymouth. It's off the Cape onto the mainland itself. But I want to include it because if you look at the edges here and all around here, you will see that there's a boundary, so that this was actually a lower area which they took advantage of to raise the cranberries in. One thing about Cape Cod is water, and water can be a real problem there. And so here's what we have at this picture here is the freshwater and the saltwater interface. And that is the boundary between freshwater and saltwater that's underground. And if you notice that this water table here, it's U-shaped. Okay. And notice that the fresh groundwater can also be above sea level. Rain and snow are the only freshwater water sources on the Cape. The soil is porous, as mentioned earlier, and it absorbs most of that water. The Cape waters include coastal waters, freshwater ponds and streams like those kettle ponds, and groundwater. Talking a little bit more about the freshwater saltwater interface. If you look at this top sketch here, you'll see that the freshwater, the seaward movement of the fresh water prevents the saltwater from encroaching. Okay, and you can see it here. The fresh water is pushing up here, and the salt water is meeting that boundary, and I'm going to say it's respecting the boundary. Now, what happens with saltwater intrusion? And this would become a number of ways this could happen, but the example here is someone put a well in and was taking water out of that aquifer. Well, what happens is that when you start doing the groundwater pumping, it reduces the freshwater flow towards the coast. And what happens is that the salt water is pulled up towards the aquifer, and the water table itself ends up being lowered. So saltwater intrusion happens, water table's lowered, the freshwater saltwater interface is weakened, and saltwater starts intruding into the freshwater aquifer. In the Cape, there's a number of groundwater pools, and they're referred to as lenses. And think about lens like a lens on a glasses or a magnifying glass. They are thick in the middle, tapering to thinner edges. Okay. And the water table itself in the Cape is not, and I'd say this probably everywhere, it's not horizontal. There are high and low places in the water table. And if you're under a hill, you're going to have a higher water table. And if you look at these, you'll see these numbers here. There's 5, 15. This is the is the elevation of the water above sea level. And it goes as high as 60 feet in some of these places here. So the water is down there, and it's in lenses. And one thing to make note of is this Toro and Yarmouth cross sections. As far as the Yarmouth cross section, you can see here's the groundwater, and keep in mind where there's fresh groundwater and there's saline groundwater, that's all glacial till or glacial deposits. So at the Yarmouth cross section, you can see the groundwater itself goes right down to bedrock, or to sand, silt, and clay that's down here at the bottom, below where the salt water is. If you move up to Toro, which is further out towards the end of the Cape, you'll notice that the groundwater is completely surrounded by saline groundwater. Talk a little bit about horseshoe crabs. They're an important part of the species that live on the Cape. The horseshoe crabs themselves have been around for 450 million years. They've been around longer than the dinosaurs. Horseshoe crabs eat worms and mollusks and whatever they can find in the sand. They are preyed upon by sharks and loggerhead turtles. Horseshoe crabs are harvested for bait and for bleeding. They have a blue blood that is very sensitive to toxins, toxic bacteria, and it's used to test vaccines and other medical preparations. And one of the other things is migrating shorebirds stop by and eat horseshoe crab eggs in mass. Horseshoe crabs, peak spawning period is in May and June. They lay their eggs in the sand, then they get fertilized. They prefer leaving the water at night, usually during a full moon. So somebody got lucky and saw a bunch of them out during the day, yeah. These are horseshoe crabs mating. This is the female horseshoe crab. Females can be 1 to 4 times bigger than the male. Generally, they'll get quite a bit larger. And this is the male. What the male does, and it's got little claspers down here, part of their legs. The first ones are claspers. They will grab a hold of the female shell. And as the female is walking through the sand, depositing the eggs, the male is behind it, fertilizing them. One of the things to note here is you'll see that this crab here has kind of a rounded ridge here. That means it's a male, and only the males are so rounded, and the reason for that is so that they can clasp a hold of the female and actually fit onto the female shell. Cape Cod is an important feeding and resting area for migratory birds, much like the Bay of Fundy or many of the other places along the coast. There are about 20 species of migratory birds that stop on the Cape while they're doing their migration. And the Cape itself is habitat for more than 370 bird species. So good place to go if you're a birder. These particular birds here are red knots, and they're down, and obviously they're looking for some eggs here. And I'm looking at this horseshoe crab. You can see that roundedness at the shell. That would indicate that this is a male. Since 1980, the red knot population has declined about 75%. In that same time period, and what we're seeing today, horseshoe crabs are overfished. There has been a steep decline in the breeding areas, and one of the major breeding areas is the Delaware Bay in New Jersey, along with the Cheshire Bay, etc., along the coast. All right. With that steep decline of the horseshoe crab population, that means it's a lot fewer eggs for the migrating birds. And like this bird here, the red knot, 75% population decline. But what does this bird do for migration? It goes 9,000 miles from the Arctic tundra, where it lays its nest and breeds, and it goes to the tip of South America in the winter. So it's important for this bird to have nourishment on the way. And the red knot itself is about 9 to 10 feet long, and the wingspan it goes up to it's a 19 to 21-inch wingspan. So it's a fair-sized bird. As I mentioned earlier, the horseshoe crab blood is used in vaccines because it's very sensitive to toxic bacteria. And herein lies one of the problems with horseshoe crabs. They are bled for that blue blood. The bleeding takes about half of the crab's blood. The mortality is unknown. It's estimated at 20 to 30% or more, but there is no government agency that requires mortality records to be kept. And there are 5 labs that do this bleeding, and they don't keep records of it either, at least not to the public. Okay, as mentioned, the breeding areas are showing a significant population decline. One of the things about the use of this blue blood is that for the past 15 years, there have been synthetic alternatives that could be used for this testing of vaccines, etc. And I got this out of an article, and it might be cynicism, but on the part of the writer. But one of the reasons why there hasn't been a shift to the synthetic alternatives is that the companies already have their infrastructure set up to bleed these crabs. And why ruin the perfect infrastructure and let it go to waste when there's still crabs out there? At least that's what I think they're thinking. One of the things, too, that was noted is that oftentimes when fishermen catch the crabs, they might get, I'm going to say, manhandled, and they might get picked up by the tail, whatever. That is probably not the best way to treat a crab if you want it to live. Okay, getting down towards the end here, and I hate to go on a negative note, like crabs being bled and dying, and this picture here showing the areas of the Cape that are most likely to be affected by climate change. And obviously the reddish and orange areas are those areas that will be most affected. And going to end the presentation with a space shot from the International Space Station on June 4th of last year. So when I look at this, I always think of the movie E.T., like with the finger, E.T. phone home. It always reminds me of that. Anyway, so if there are any questions, feel free. I'd love to hear them.
Thanks so much, Steve.
Yeah.
Learned a lot. If anyone has a question, you can unmute yourself and ask, or if you're more comfortable, you can type it in the chat.
Thank you for your presentation, Steve.
Oh, you're welcome. I was going to say, I can tell that like everybody's just waiting to ask a question. I know somebody is. Yes, Josephine. What you got? On mute, though. You're muted. Yeah.
Yeah. Okay. All the stuff about the sand and the kettles and all of that was fascinating. But my question has to do with your very first slide with the shark.
Yeah.
Okay. In the picture with the shark, underneath the shark is a little fish. Is that a baby shark?
Oh,
Or
I believe that's a lamprey. Hang on a second. We'll go right to it.
I just wondered what that was. That would either it's its own baby, or it's pretty brave to be that close to.
Yeah. Can you see that picture?
Yeah.
Okay, I am sharing it. All right. Yeah, I believe that's just like it's not a lamprey, remora.
Oh.
What they are is they're something that will they're like a parasite that will hang on to the shark. And I think that's what that is. And you know, there's another type of shark called a cookie cutter shark. And it's a small, they're small like that, but what they do is their mouth, you'll know why it's called that if you saw the market left, but it's got a round mouth and it will leave a round hole in the fish that it's biting on. So I'd say it's either one of those. It's not a baby shark. If I would say it would be brave because white sharks do eat fish, and I know that some sharks are cannibalistic. You know, if it's moving and it fits in its mouth, it's liable to go down.
But thanks. Just wondered.
Steve, you have a couple of questions in the chat here. The first one from Molly, you mentioned the effect of drilled wells on the groundwater.
Yeah.
What's the effect of all the septic systems on the Cape? Do you know?
Well, you know, I'm glad you brought that up because just recently there was an article about that. I can't remember if it was in the Guardian or the Portland Press Herald, but it's a real problem on the Cape. And nitrogen, there's nitrogen that comes from the untreated septic system wastewater. On the Cape, about 85% of the homes use septic systems. There are 6 water treatment plants on the Cape, but those are mostly for the population areas. The problem with the septic system, as might be noted by the question, is that that water is not treated. So the untreated septic sewer water literally goes over into the soil. That causes excess nitrogen in the waters, and that has caused algal blooms, and beach closures themselves on Cape Cod are common. So yes, the septic systems do cause problems.
Steve, there is one more question in the chat. How similar to the Gulf of Maine was the Cape's development?
Well, it all happened. I don't want to say it happened at the same time, but it was pretty much from the same event because let me put it this way, opposite sides of the same event. The Gulf of Maine was formed when the glacier went through and scraped up the rock. And, you know, one of the reasons why that you'll seldom find, or you won't find dinosaur skeletons in Maine is because the glaciers have dug up so much of the soil and the Gulf of Maine itself. The thing about Cape Cod is that's pretty much where the glacier ended. Actually, the terminal point of the glacier was more like Nantucket and Martha's Vineyard. And then when the glacier started melting, then it stopped at a point where Cape Cod is, and at that place dumped I think 300 to 600 feet of till or material there. So it's the same thing, the Ice Age, but the Gulf was formed at one end of the process and the Cape itself at the other end of the process. I'll have to admit.
Go ahead, Steve.
I was going to say, in dealing and doing the project on the Gulf of Maine, when I first started it, I didn't expect geology to be such a big part of it. But it actually it is.
I don't see any other questions. Oh, wait a minute. What is the consequence of the Truro cross-section with the freshwater being completely surrounded by saltwater?
Well, with the way the freshwater saltwater interface works, the freshwater is pushing up against holding the saltwater literally at bay. One of the problems that would come out, like the saltwater intrusion, is okay, those houses that have the septic systems, they probably don't have town water. They probably have a well and they're pumping from the well. And surface water on the Cape is drawn down. So if too much water starts getting drawn down, you're going to start seeing more saltwater intrusion into the aquifers. And something interesting on this too, and I got this with one of the tree walks with Elaine Willard at the reserve itself. And this was like after this past winter's storms. They were talking about how the waves or the seawater came up and actually flooded where the trees were. Eventually that's going to hurt the trees, probably even get into the groundwater if it stays there long enough. But it's probably not going to hurt that aquifer if it just comes and goes really quick, even though it's still going to not do the trees any good.
Couple other questions. One is, how far north do horseshoe crabs spawn? Anything we can do to help preserve them?
I could be an anti-vaxxer here, right? No, but I'm not. But I know that they are in Great Bay in New Hampshire, and I saw some there last year when down at the Great Bay. I don't know how much further north they go. I have not seen any in our local area, but Great Bay itself is probably what, 20, 30 miles south of Wells. So give you an idea.
Steve, I've seen them in Damascata. Oh, and Karen said that too. Yeah.
Okay.
That's as far north as I've seen them. Another question, where did the ashy podzol soil come from?
I'm not sure. I'm suspicious that, here you have literally Cape Cod was a pile of sand, maybe like 6,000 years ago. And I'm thinking that stuff landed on it, water leached through the sand. Possibly there were minerals in the sand that caused it. Not sure the exact origin of it. And I've seen that type of soil, and I never knew what it was, but I've seen it in digging, like digging around my parents' camp. Did a lot of digging there. Too much.
Looks like we have 1 minute left. Our last question. There's a thank you in the chat.
Well, then I'll mention one thing here, and Suzanne had mentioned on April 18th, we're doing one more lunch and learn. And it's kind of interesting because I have 4 different topics that are put together that didn't quite fit into other areas, but they were too good to leave out, so to speak. There was a lot of information in them. And so what I'll be covering with that is the actual formation of the Gulf, geologically, the food web of the Gulf, and it'll be throughout pretty much the whole ocean. A bit about right whales and some of the issues that they deal with and some of the things that they need, and also sea changes that we are currently seeing, and that could have negative impacts on ocean life in the future.